Okay, welcome back AP Stats. Today we're going to take a look at section 4.1 and we're going to talk about sampling and surveys again. And our learning target today is to learn about how to use a stratified random sample and a clustered sample. And we're going to distinguish between the two and give an advantage of each method. So far we've been talking about how to take a simple random sample. But unfortunately, it is usually very difficult to obtain a simple random sample from the population of interest. It is often costly in time and money. So again, we want to remember SRS when we read that. It stands for simple random sample, because today we're going to talk about a stratified random sample, but that is not what SRS stands for. It stands for simple random sample. So the first type of sampling method we're going to take a look at is called a stratified random sample. To select a stratified random sample, first classify the population into groups of similar individuals. We call them strata. Once we have them classified, we will then choose a separate simple random sample in each stratum and combine these simple random samples to form the full sample. So then choose a separate simple random sample in each stratum and combine these simple random samples to form the full sample. Okay, so let's take a look at if we were talking about the population of HF2 high school. How could we break the population up into groups of similar individuals, or strata? So if we think about this, one way we could break the population of HF2 high school students up into similar groups of individuals is to break them up by grade. So our strata could be 9th, 10th, 11th, and 12th grade. Now notice I already have the notes written, so if you need to pause the video to copy these down, please do so and then continue on. We want to choose the strata based upon facts known before the sample was taken. If the individuals in each stratum are less varied than the population as a whole, a stratified random sample can produce better information about the population than a simple random sample of the same size. So when we're doing a stratified random sample, we're seeking little variation in the stratum. The reason we do this is to help us capture the variation in the population. I also just want to add that as we take a look at the strata that we broke our population of HF2 high school students up into, we broke them up into strata of 9th, 10th, 11th, 12th grade. Again, strata is the plural form, meaning more than one group. 9th, 10th, 11th, 12th grade, each group is similar within. In a stratified random sample, again, each group is going to be similar within, but different across the groups. So we break them up into the strata, and then after we classify the 9th, 10th, 11th, 12th grade, we're going to go through, we're going to choose a simple random sample from each group. So we might choose a sample of 10 students from 9th grade, 10 students from the 10th grade, 11th grade, and 12th grade, and we will put each of those students together to form our complete sample. Okay, so now let's take a look at cluster samples. To take a cluster sample, we're first going to divide the population into smaller groups. Ideally, these clusters should mirror the characteristics of the population. Okay, so that's where this is going to be different than the stratified sample. When we did the stratified random sample, each group of individuals were similar within, but the cluster, each group is going to mirror the characteristics of the population. Well, in a population of whatever our individuals are, whether they're people, objects, whatever they may be, they are not all going to have the same characteristics. So the groups in the cluster sample are going to be different within the group. So we will break these, we'll break them up into clusters that mirror the characteristics of the population. Then we will choose a simple random sample of all the clusters. All individuals in the chosen clusters are included in the sample. So again, if we take a look at the population of the Henry Ford II high school students, how could we break them up into clusters? Well, we want to have each group mirror all the characteristics of the population of all the students. So one of the ways we could do this is we could group them into lunch A, B, and C. Another way we could do this is to go by the counselor breakdown, the alpha order. We could choose those to be our clusters. Once we have them broken up into clusters, say that we choose lunch A, lunch B, lunch C, we will then choose our simple random sample from each one of those lunches. And we will take that simple random sample from each of those lunches and put them all together, and they will be the sample that we are going to use to gather our data from. So cluster samples are often used for practical reasons. They do not offer the statistical advantage of better information about the population that stratified samples do. So again, we use them for practical reasons. That's why many times we will choose to use a cluster sample, but they do not offer the statistical advantage of better information about a population that stratified samples do. So we're just going to take a quick look at the breakdown of a cluster versus a strata. So clusters divides the population into clusters, and we take individuals from some of the clusters. Okay? Ideally, the clusters will be different within, but similar between. That's the key thing we want to remember. They're going to be different within the group, but each group will be similar as we go across from group to group. Efficiency is the primary benefit. Okay? Efficiency is going to be one of the main reasons that we would use cluster sampling, but we want to make sure that we understand that this is not a convenience sample. Ideally, the clusters should look like the population. And when we take a look at strata, again, we're going to divide the population into strata and take some of the individuals from all of the strata. So we take some from all. Ideally, they are going to be similar within each group, but different between the groups. The advantage of doing a stratified random sample is we're going to be able to gather better information about the population. We're going to have less chance of over or under representation when we do this. But one of the disadvantages is that it's hard to use when populations are spread out. Okay? So you may even want to label that, again, this is your advantage, this is your disadvantage. Over here, efficiency is the primary benefit, that is the main advantage for cluster sampling. Let's take a look at example 4. Again, the example will be pre-written as we talk about it. So listen as I talk about the example and go through it, pause it, and then copy down the notes. The student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium about use of the school library. They would like to announce the results of the survey at the end of the assembly. The student council president asked your statistics class to help carry out the survey. There are 800 students present at the assembly. A map of the auditorium is shown below. Note that the students are seated by grade level and that the seats are numbered from 1 to 800. Describe how you would use each sampling method to select 80 students for the survey. Give advantages and disadvantages for each. When we describe these, we are going to use the technology method to carry out these sampling methods. So let's take a look at the first one. How would we use a simple random sample to carry out this survey? So we have 800 students in this auditorium, and we're going to select 80 students for a survey. So to take a simple random sample, we need to choose 80 of the seat numbers at random. Using technology, we can use our ranInt function from 1 to 800, where 1 represents the first seat, 800 represents the last seat. We'd use the ranInt function from 1 to 800 on our calculator until 80 different seats are selected. Now remember, you may get repeats as you are using your calculator, and you will have to ignore the repeat and make sure that you have 80 unique numbers. Once you have the 80 different seats selected, you will then give the survey to the students in those seats. What are the advantages and disadvantages of taking a simple random sample? Well, an advantage is that this method is very easy to execute. But a disadvantage is we could possibly have an over or under representation of part of the population that could occur. For part B, how would you conduct the survey using a stratified random sample? We want to remember that a stratified random sample means we are going to select groups that are similar within each group but different across from group to group. So if we think about this, library usage might be similar within grade levels, but different across the grade levels. So we'll use the grade level seating as our strata. Again, if we take a look at the chart here, it tells us that the 9th graders are in seats 601 to 800, 10th graders in 401 to 600, and so on. So within each grade seating area, we will select 20 seats at random. Now, why do we select 20 seats at random? Because we wanted a total of 80 for our sample, and we have 4 grades. So we will randomly choose 20 seats from each grade. So how would we continue to do this? Well, for 9th grade, we would use the ranint function from seats 601 to 800 to select 20 students. For 10th grade, we would use the ranint function from 401 to 600 to select 20 seats. For 11th grade, we use the ranint function from 201 to 400 and then select the 20 seats. And for 12th grade, we use the ranint function from 1 to 200 to select the 20 seats. We would then give the survey to the students in these selected seats. What is the advantage of using a stratified random sample? The advantage would be there would be no chance of grade over-representation. The disadvantage is that this would be hard to execute. How would we give the survey if we were to use the method of cluster sampling? Again, cluster sample means that they're different within each group, but similar between. So if we think about this and we look at the way the seating chart is, each column of seats from the stage to the back could be used as a cluster. Each column would contain all 4 grades. And again, if you look at this, we can see that the 12th grade were all the way up in the front with the 9th graders being all in the back. If we count, we would see that there are 20 columns. If we were to go through and count, there are 20 columns. So we would have 20 clusters with 40 seats each. So what we would need to do then is we would go ahead and we would need to choose 2 clusters to get 80 seats in which we're going to give that survey out to. So since there are 20 clusters, what we will do is we will use our ranint function from 1 to 20. This will help us choose the 2 columns in which we will give the survey to. So use random integer from 1 to 20. You'll select the 2 clusters from this random integer 1 to 20, and then you'll give the survey to all 40 students in each column. The advantage of this, it's very convenient to execute. Each grade will be equally represented in each column. A disadvantage that could occur is that if there happened to be some kind of pattern in the seating, something we may not have been aware of. For example, like we could have had all AP kids just happen to be in one column, we would have a chance to over or underrepresent a certain group. So that would be one of our disadvantages. So again, take some time to read over these 3 examples, and then when we return to class, we will continue on and we will you guys will attempt to go through the check understanding.